here is a bit of diagram. So what this cell will do, it will push a charge. The charge will go and deposit here. No, don't show charge at one point. You have to show everywhere on the surface of solid cylinder. Then induce a charge on inner surface of cylinder. Then from outer surface, that charge will enter negative terminal. So like this, we have here a charged plate, positive charge plate. The inner surface of cylindrical shell will be negatively charged. So for your help, at least I can. It's a long this one. So here what we get we get a charges. You have to show on either side, but these are not plates. So actually it's a cylindrical, no? It'll be like this. Okay, fine. So you have everything like this. So how the electric field will be radially outward? Whose help you have to take it? It's asking capacitance per unit length. Since we don't have much better idea, so therefore, let's first calculate the electric field. So how to bring the electric field? Can you use same formula? Electric field due to long wire. Can I use same formula? Electric field due to long wire. Yes, the same formula. But sir, what about lambda? Lambda is what? Again, I'll put charge per unit length. Still will stick on to the same equal to lambda by 2 pi f naught r. Any condition for r must be greater than a, less than b, greater than a. Is it okay? So this is that r. This is electric field. Now dv is equal to minus of e dr. We will integrate. This will be v plus v minus. The limit will be from a to b. So then v plus v minus. So v minus of v plus equal to minus of. This will be a to b. The electric field is given by 2 pi epsilon naught r dr. Sir, how you're writing it? I will treat this b very much b greater than a is telling the charge will deposit it. This is like some charged wire only. And we are calculating field outside. You apply Gauss law, you'll end up this much only. So what to do lambda, what you're going to do, and we'll see further. First, we'll get the potential difference. So this will become v plus v minus. I'll send negative sign to LHS. So lambda by 2 pi epsilon naught, I'll let it be outside, dr by r. Log of b by a. What is lambda? Lambda will become charge per unit length. From where the charge is provided by cell, no, and let be n. So capacitance per unit length is asking. So if you better what you write, dq by dl you write it, or q by l, anything. So lambda, what we can write it as q by l 2 pi epsilon naught log b by a. So this should be equal to potential difference. V, I'll write it. So this, what is V further? Q by C, equating. So Q by C is equal to Q by 2 pi f naught L log of B by A. Capacitance per unit length is asking.
Sir,
Let me finish off. So capacitance per unit length will be C by L equal to 2 pi epsilon naught. Yeah, somebody?
sir, why did you take the electric field as same that of a long wire, sir?
You apply Gauss law?
Okay.
Apply Gauss law. But sir, it's a thick wire or thin wire, the field outside will be same. Capacitance per unit length it is, because since it is long. Okay, sir, now is it what we are using in fan? But we don't see long node there. But tell me what I should do. What do you mean by long? See, I think your math should be very strong here. What do you mean by long here? If the length very much greater than radius, it is said to be long. If the length is very much greater than radius, it is said to be long. So therefore, the capacitor which I consider, see that the length is greater than radius, at least 3-4 times. That is enough. It will become long capacitor. Some approximate, but that is enough for me. In manufacturing also, I'll just take care about that conditions only. Long doesn't mean that it should be infinite. If it is infinite, how you put in fan? So here for practical applications, theoretical, okay, with it. For practical applications, long in the sense length greater than radius, that is enough. In electrostatics, we didn't have this discussion because there it was like a very highly theoretical, but now we have to be very, very practical. Here long means length greater than air. So here I'll write for your, in advance may not be, but for when you go for Olympiad, I think definitely you need to higher practical knowledge also needed. You can't just only practice questions and